here's the evaluate of the, and so that one just, flips the channels, not very interesting. These are running on the, via LLVM. So the frame rate's around, for the simple ones is around like 10, 12 frames a second on this laptop. And for some of the nasty ones is more like 5. Now, we're getting a lot better performance on machines with a lot of cores and stuff, but this machine's about 2 years old at this point. So Pixelate is gonna, doing that. Twirl. So now this one's a nasty one, because it's going to basically to evaluate one pixel, it's got to look at a bunch of other pixels, the high order bit, and it has these. They're the needed and change functions, kind of somewhat complicated to determine how much of the input you need to do the output. You can kind of see the there, and that moves around. Pretty cool. Okay. All right, so like I said, it's a lot faster on GPU. This isn't surprising. What's slowing us down? Honestly, the mea culpa part is we're not using LLVM as well as we should. We generate some sort of wordy IR. We do more loads and stores than we need to. And that's part of my goal is to make life better for us along those lines in the next go around. We didn't use as much SSC as we'd like because we have the call stack issues. Like I said, I believe that's been fixed in the main line, but we're a little bit back from the main line at this point. Some of our callbacks are kind of not as well written as they should, and we also have some security and numerical error trapping stuff. Well, we can kind of skip this. Basically, GPU math is goofy, and some of it we have to deal with, and also PowerPC int divide by 0 just silently produces a 0, which seems to me to be the exact worst number you could possibly return. And so we have some stuff in there to check for these conditions. So on the GPU, you're kind of protected from numerical instability in 2 ways. One, a lot of things that should result in infinities go to 0, and those tend to propagate a little bit better. And then the GPU driver just like lobs a nuke at you if you take too long to run. The CPU, that doesn't help you. And so we have some callbacks, and we're looking at some threading, out-of-process execution, various things to allow us to kind of kill the process from afar without having to constantly be pinging, hey, should we continue? Hey, should we continue? Security, this is a local sort of vectors and array accesses that take in sort of unknown sort of offsets, cause trouble. We had to trap for those in the current go around. We basically check array bounds when we look at them if we're looking at something that's non-constant. Okay, so here's my please don't throw things at me 2 slides. So here's the main challenges we faced using LLVM so far is probably Windows and Visual Studio integration are our main one. We use Visual Studio and the Intel compiler at Adobe to produce most of our software, and I think that's pretty common. But Visual Studio is not integrated into the LLVM testing at all, so it sometimes breaks. We had stack alignment issues in SSE that were a problem. Like I said, I believe that's been fixed. Ditto for Win64, we had some issues with it, but Anton's done a lot of really great work to kind of make that go, and so I'm really kind of happy with that. But LLVM can crash, asserts. So we're creating the IR, so it crashes when I do something dumb, but bugs happen, and so, some strange program someone writes that touches something in the compiler that causes a bug that all of a sudden crashes and then causes a point product to fail or to crash is bad. So requires to keep it in process in a JIT way really requires a lot of testing and a lot of, kind of a little bit of worry. In terms of staying on the main line, the API instability and check-in velocity of LLVM is it's a bit of a challenge. If your goal is to sort of stay with the main line and you're sort of integrating it into a much bigger system that's cross-platform and stuff, it requires a lot of of work. So some things that were a little problem is the platform-specific leaking into the IR, like vectors, and we do PowerPC and Windows, and like Float2 versus Float4, and originally I was using Float 16s for matrices and stuff, and had to get rid of those. And I'd love sort of more matrix stuff, but anyway, this is now I've been told, somebody was very incredulous about the statement. This is all the libraries on my system. Now maybe I'm compiling it not as well as I should, but LLVM is kind of big, and at least on my system. This is on the Mac. 27 megabytes of libraries worth for the release, and 270 for the debug release, the debug build. And clients take up and look at, they take notice of that when they see it. And in comparison, in terms of the flash download version 9 is 1.5 megabytes, which is one of the other reasons our flash support for hydrobyte code is not using LLVM. All right, so what we're going to work on, like I said, what I can't talk about, we also have some ideas for some optimizations related to our own kind of execution model that we're thinking about that we're not ready to talk about. Better LLVM I want to make. And so these are things we'd like to make use of LLVM in a better way than we are now. And we'd like to become more of a producer of LLVM, help out more. But as to date, we haven't really been good about that on my team. And suggestions on the kind of things that would be helpful to you would be great. All right. Thank you. LLVM was really useful. And it's been a whole lot of fun working with it. Cross-platform's been our main kind of thing that's made it kind of hard to work with. But we were able to make that go, and that's cool. And if you want to play with PixelBender, there it is. And you can also search for those terms. Questions? Thanks. Oh, actually, I think he was up first, so I'm going to. Our GLSL path was the thing we worked on first prior to starting to use LLVM at all. So when we go to when we squirt out to the GPU, we are actually squirting out to GLSL and calling through the OpenGL routines. Now, I think we would like to unify some of our kind of pathways through the system, so that may change.
So, how do you compile one program to both LLVM and the other?
Well, there's part of the program is the things that are on a per